Polynomial operations. If you look at the word polynomial and break it down, poly means many and nomial is a number, many numbers. Polynomials are just variables with powers and numbers, or they could be constants or coefficients, put together with addition and subtraction and division and multiplication. If you have a polynomial, like 3x to the fifth plus 5x to the fourth minus 6x cubed minus 2x squared plus 1, you need to know that terms are separated by plus and minus. So this thing right here has 1, 2, 3, 4, 5 terms. If a polynomial has one term, it's called a monomial. If it has two terms, then it's called a binomial. If it has three terms, then it is a trinomial. 4 and beyond, we just call a polynomial. This one has 1, 2, 3, 4, 5 terms. We just call it a polynomial. But more than just that, we name them by their powers. If the highest power is 5, it's called a quintic. But let's start with the powers. So a power of 1 is a linear polynomial. A power of 2 is called a quadratic polynomial. A power of 3 is called a cubic polynomial. 4 is a quartic, think 4 quarts in a gallon, quartic polynomial. And 5 is a quintic polynomial. So this one right here has 5 terms. It would be a quintic polynomial. And if I had x cubed plus 2x, the highest power is 3. We name it by the highest power. That would be a cubic binomial because there's 2 terms separated by addition. If I had x cubed plus x squared plus 2x minus 4, 1, 2, 3, 4, that's 4 terms, so it's just a polynomial. It would be called a cubic polynomial. And x cubed plus x squared minus 1 is a cubic trinomial. We name it by its powers, its highest power, and the number of terms. When we write a polynomial, we put it in what's called standard form. Standard form, if you take a look at the way it was written on the previous page, is normally highest power down. But it's actually more than just power. It's by what's called degree. This is just a little bit confusing. If I take a single term, the degree is the sum of the exponents. If I say 3x to the fifth y squared, this one has degree 7. And if I take 3x squared y to the fifth, it still has degree 7. But if I add, say, 2x to the fourth y squared, this polynomial still has degree 7. Because in a polynomial, the polynomial is described by its highest degree. And again, we go highest degree down. The first term here has degree 7. The second term has degree 6. A constant has degree 0. When I say x cubed plus x squared plus 2x minus 1, this term has degree 3. This term has degree 2. This term has degree 1. And this term has degree 0. Now you could think of it as minus 1x to the 0th. Reminder, what is x to the 0th? Anything to the 0th power is 1. So this is actually 1 times 1, which is 1. Now, of course, we don't put x to the 0th there, but if I give you a constant like 5, it has degree 0 because it's 5x to the 0th, which is, of course, 5. 5 times 1. When we write a polynomial in standard form, we write it as highest degree down. The degree is the sum of the exponents in a single term. Now, keep in mind one more time, the confusing thing, the thing you might forget, is when I have a polynomial, more than one term, the degree of the polynomial is the degree of the highest term. So last example, if I had 7x to the 8th y squared plus 4x to the 5th y to the 3rd minus 2x cubed y squared plus 1. This has degree 10, this has degree 8, this has degree 5, this has degree 0, and the highest degree term is 10. So the degree of this polynomial is it's a 10th degree polynomial. In a polynomial, again, the degree of the polynomial is the degree of the highest term. That's why when you say x cubed plus x squared, we call it a cubic, because the highest degree term is 3. When we add and subtract polynomials, we can only add and subtract them if they're like terms, meaning they must have exactly the same variable part. When we have x plus 3, we can't add those two. Students always want to make this 3x, but it is not equal to 3x, clearly, because this is x plus 3 and this is x times 3. They must be like terms. When we say 3x plus 2x, that is, of course, 5x. And that's because whatever x is, it's a number. For example, if I say 3 times 10 plus 2 times 10, that is, of course, 5 times 10. There are 5 tens, just like here there are 5 x's. They must be the same exact number for you to be able to add them. If I ask you to add 3x to the 5th plus 8x to the 5th, students always want to make that 11x to the 10th, but it is not x to the 10th. This number, how many of those numbers are there? There are 11 of them, 11x to the 5th. So when we add and subtract, we add and subtract the coefficients on like terms. And the thing you need to remember is when you add and subtract, the powers never change, ever, under any circumstances. They must be like terms. You add the coefficients, and the powers never change. When we multiply, say, 3x times 2x, remember that this is 3 times x, and this is 2 times x, so you're multiplying everywhere. Remember that you can multiply in any order. 2 times 3, 3 times 2, both are 6. So I can multiply in any order. Of course, I'm going to multiply my numbers. 3 times 2 is 6. And x times x is, of course, x squared. When we multiply 5x to the 4th times 3x squared, we're going to multiply our numbers. 3 times 5 is 15 because we can multiply in any order. X to the 4th is x times x times x times x. There are 4 of them. This is getting multiplied by x squared, where there are 2 of them. And if we count all those up, they're going to be 6 x's. And that means there are 6 x's multiplied. That's x to the 6th. When we multiply 7x cubed y squared times negative 3 x to the 4th y cubed, we can multiply in any order. 7 times negative 3 is negative 21. There are 3 x's here multiplied and 4 there. That means there'll be 7 altogether. And there are 2y's and 3y's, and that's y to the 5th. When we multiply the coefficients and we add powers on like bases. Don't confuse this with adding. You can only add like terms. When you multiply, that's completely different. Third case here. Power to a power. That's the power rule. X cubed squared is x cubed times x cubed. We know that x cubed is x times x times x times x times x times x. If we count those up, we see that there are 6 x's multiplied. This then is x to the 6th. X squared to the 4th power is x squared times x squared times x squared times x squared. There are going to be 4 of them. There are 2 here, 2 more there, and 2 more, and 2 more, and there are altogether 8 of them. This is x to the 8th. It doesn't take too many examples before we recognize that there's a shortcut here. I don't need to write all these out. I just need to recognize that 2 times 3 is 6, and 2 times 4 is 8. So in fact, you multiply your powers when you have a power to a power. This is the power rule. However, there is a common mistake that students make. Students recognize that it's a power on a power, and they remember often that you multiply your powers. However, when there's a coefficient, you have to understand that that coefficient is to the power, and the coefficient itself is not a power. If I say 3x to the 4th cubed, for example, that's 3x to the 4th times 3x to the 4th times 3x to the 4th. Notice that 3 times 3 times 3 is 27. There are 4x's and 4x's and 4x's. That's x to the 12th. See how 4 times 3 is 12? But notice that 3 times 3, and that's what students do, they want to make this 9x to the 12th, which is wrong. This 3 in front, the coefficient, was to the 3rd power, and 3 to the 3rd power was how we got that 27. 3 times 3 times 3. So you take the coefficient to the power and you multiply the exponents. So when does this occur? If you have a power to a power, or parentheses to a power, you multiply your exponents, yes, but you take your coefficient to the power. 3 cubed here is 27. So one more example. If I said 4x to the 5th squared, I'll take the 4 and square it. Notice that's not 8, it's 16. 16x to the 10th, because I multiply my powers when I have a power on a power. 4 squared is 16. 4 times 4, not 8. Lastly is dividing. When we have a problem like x to the 7th over x to the 4th, understand that this is x times x 7 times. Divided by x times x times x 4 times. And notice that anything divided by itself is 1, and there are 3 left. And you might have already guessed, hey, couldn't I just subtract my exponents? 7 minus 4, to see how we canceled 4 of them right here? 7 minus 4 is 3. And yes, you're correct. And think about it, that kind of makes sense. If when you multiply, you add your powers, doesn't it make sense that when you divide, you ought to subtract your powers? That is correct. However, we run into some issues. The issue being that if the numerator power is smaller than the denominator, like x squared over x to the 5th, 2 minus 5, and it is correct, you take the top one minus the bottom one, is x to the negative third. This is actually a correct answer, it's just not the answer we want. Now, if you know what a negative power is, the negative power actually means reciprocal. This, in fact, is 1 over x cubed, and we're going to talk more about that later. You'd be okay writing that. We're not going to have any answers with negative powers on them. However, a better way to look at it for now is probably just think of this as canceling. You see how the numerator and denominator have two x's in common? Above I have x times x, below x times x times x 5 times. I can cancel two x's from each because that's what they have in common. I'm really dividing x out twice. Understand though, when I take out two of the x's above and I divide by x twice, divide by x squared, I'm left with 1. There's a 1 left above. When I divide by x twice below, there are two x's gone, and there are going to be 3 below. And that's how we get that answer of 1 over x cubed. If my question was 24 x to the 8th, y to the 5th, z to the 3rd, over 32, x to the 4th, y to the 7th, z to the 6th, all I'm going to do is cancel. I'll divide 24 and 32 by 8 because that's their common factor, and I get 3 and 4. The x's have 4 in common. I have 4 below and 8 above. I'm going to divide 4 x's out. This is left with a 1, just a 1, no x at all. I divide 4 out here. I'm left with x to the 4th. The y's have 5 in common. I'm going to divide 5 y's out here and 5 y's out here. There are going to be 2 left, and notice that they are below because there were more below, 7. So there are 2 left. The z's, there are 3 in common. I divide 3 of them out here and 3 of them out here, but there are going to be 3 left below because there were 6 below, z cubed. So my answer is 3x to the 4th over 4y squared z cubed. In general then, just cancel out all the common factors. That's what you do when you divide. These are the rules of polynomials. There are some things I'm not going to talk about till we get into the questions, and you may have done them before. But remember, I do a bunch of examples after this teaching part. Things like foiling, first, outer, inner, last. We have talked about that in class a little bit. We're going to do some more of that. Things like the distributive property. Remember that when you distribute, you're multiplying, so you're going to follow the rules for multiplication. You're going to multiply your coefficients and add the powers on like terms. All of this is covered in the examples from your assignment. The last thing I want to mention is you need to have these rules memorized. It's very confusing if you don't, because when you add and subtract, the powers never change. When you multiply, you add your powers. And when you have a power on a power, you multiply your powers. You can see how it'd be easy to get mixed up. You've got to recognize what you're doing. Are you adding? Are you multiplying? Do you have a power and a power? Are you dividing? What are you doing? Which rule do you use? You must have them memorized to be successful. This is a polynomial function. We're looking at this as our polynomial. It is best described as what? It has two terms, that makes it a binomial, and the highest power is 3, that makes it a cubic. So it is a cubic binomial. We have another polynomial function, a function because it's y equal, but this is the polynomial we're looking at. The leading term, when you write it in standard form where the highest degree is written first, this term has degree 8, this one 7, this one 6, this one 1, and this one 0. Terms are separated by addition and subtraction. We're talking about these signs here. So the leading term in standard form would be 5x to the 8th. The leading coefficient is the coefficient of the highest powered term, which in this case is 5. And the degree of the polynomial is not the sum of the exponents. When I have a single term, like 3x to the 7th, y to the 10th, this one would have degree 17. However, when it's a polynomial, the degree of the polynomial is the highest degree term. Here it would be 8. Keep in mind, when I have something like y equal 3x plus 1, this is degree 1, it's a power of 1, that's a linear. When I have y equal 3x squared plus 2x, the highest degree is 2, that is a quadratic. When I have y equal 3x cubed plus 6x, this is the highest power of 3, that makes this a cubic. We only sum the exponents when it's a single term, and we write it by the highest degree down. The name of the polynomial is determined by the highest degree term. In this case, it is 8. And there's probably a fancy name for 8. Google it. Here we're adding. Remember that when you add the coefficients on like terms and the powers never change. Always check to see if you have something to distribute. Here you don't. There's a 1 in front. That wouldn't change anything. You can ignore the parentheses then and then just combine like terms. Negative 6x to the 5th plus 7x to the 5th. When you add, the powers never change. That is 1x to the 5th, or just x to the 5th. Highest power down. The next highest power is the cube, so plus 9x cubed. There are no other cubes. And then the next highest power is the squared. That would be minus 2x squared. There are no other squares, but we do have some x's in common. Negative 5x plus 2x is negative 3x, and negative 9 plus positive 12 is positive 3. This is the way it should be written. Highest power down is standard form. It's listed by degree. 5, 3, 2, 1, 0. Question 11, our next example. I always get students that make silly mistakes here. That's because they're so resistant to showing work. You do have something to distribute. This minus affects everything after it. The first parentheses are just grouping. There's no number to distribute in front. You can just drop them. Negative 6x cubed minus 9x minus 8. Now distribute that minus. It's like distributing negative 1. It's going to change all the signs. Minus 6x to the 4th plus 12x squared. It's a negative 1 times a negative 12 is a positive 12. And a plus 3 becomes minus 3. Combine your like terms listed by highest power down. This would be negative 6x to the 4th. The next power is right here, minus 6x cubed. Our next lowest power is plus 12x squared. After that, we have a minus 9x. That's a degree of 1. And then we do have like terms, negative 8 and negative 3 combined together to make negative 11. And there's our answer. Always watch for a minus in front of parentheses right here, because that will need to always be distributed. In question 15, we're multiplying. When we multiply the coefficients and add the powers on like bases. Keep in mind, the base is the variable itself. I can multiply in any order. Here goes. 7 times 3 is 21. A cubed times a to the 4th. There are 3 here and 4 there. There's 7 a's multiplied. That's a to the 7th. B squared times b to the 4th. 2 and 4. There are 6 b's multiplied. B to the 6th. And c to the 8th times c to the 5th. 8 and 5. There are 13 c's multiplied. There's my answer. Multiply your coefficients. Add the powers on like bases. The base is the variable. Distributive property. Distributive property is multiplying. And when we multiply, we're going to multiply our coefficients and add powers on like bases. So I'm going to take 10 times 7, that's 70. X to the 5th times x to the 7th is x to the 12th, adding my powers on like bases. X to the 5th times x to the 4th, well, don't forget 10 times 6, that's 60. And 5 and 4 make 9 x's multiplied, minus 10 times 2 is 20, and x to the 5th times x to the 1st, there's 1 there, is x to the 6th. Keep in mind I can't add any of these because they're not like terms. They must be the same power to be like terms. FOIL, quick review. FOIL is a special case of the distributive property. Notice we're multiplying. What I'm going to do is take the 4x times 5x, 4x times positive 6, negative 3 times 5x, and negative 3 times positive 6. Often we use the acronym FOIL, first, outer, inner, last. 4x times 5x is 20x squared. 4x times positive 6 is positive 24x. Negative 3 times 5x is negative 15x. And negative 3 times positive 6 is negative 18. Usually when you FOIL, there's stuff in the middle that will combine. They're like terms, I can add them. 20x squared plus positive 24 and negative 15 make positive 9x, and then minus 18. Students often mess up a problem like this because they think they can distribute the exponent. They're confusing that with something like 3x squared y to the third, say, cubed, which you're multiplying between your things. 3 cubed would be 27, 3 times 3 times 3. X squared cubed, this is a power, and a power would be x to the 6th. Y cubed cubed would be y to the 9th. I'm multiplying my powers, but I take my coefficient to the power. Keep in mind this 3 out front has a power of 1. If there's no power, the power is 1. And you do take 1 times 3, which is 3 cubed, which makes that 27. Don't confuse that with adding and subtracting. When I say x plus 2 squared, I have to remember that that's x plus 2 times x plus 2. You can't distribute the exponent. This is not equal to x squared plus 4. If you want to see why, just take an example with numbers. When I say 3 plus 4 squared, this is not equal to 3 squared plus 4 squared. If it was equal to that, it'd be 9 plus 16, which would be 25. But hang on a second, 3 plus 4 is 7, and you can see that 7 squared is not equal to 25. You can't distribute an exponent over addition and subtraction. It just does not work. So what you need to do with this question is write it out twice and FOIL it. It's the same as the last question. First, outer, inner, last. Think of it as distributive property. Take the 6x to both, take the positive 5 to both. 6x times 6x is 36x squared. 6x times positive 5 is positive 30x. Positive 5 times 6x is positive 30x again, and positive 5 times positive 5 is positive 25. Notice the middle combines to 60x. 30x squared plus 60x plus 25. The acronym FOIL, first, outer, inner, last, only works if you have two binomials. That's why I said think of it like the distributive property. And that's what you're doing here. You're going to take the x to all three, and then you're going to take the negative 4 to all three. So you just have more multiplications. It's the same process. X times 9x squared is 9x cubed. X times positive 6x, x times x is x squared. X times positive 8 is positive 8x. Now take the negative 4 to all three. Negative 4 times 9x squared is negative 36x squared. Negative 4 times positive 6x is negative 24x. And negative 4 times positive 8 is negative 32. I have more like terms here. There's a pair. This is 9x cubed. Combine your like terms. Minus 30x squared. Positive 8x minus 24x is minus 16x. And lastly, we have that minus 32. This is the power rule. A power to a power, or parentheses to a power. Remember, the exponent on the 4 is 1. I only multiply exponents, so it's going to be 1 times 3. In other words, it's 4 cubed. 4 cubed is 4 times 4 times 4, which is 64. The shortcut here, rather than write this out 3 times, 4z to the 19th times 4z to the 19th times 4z to the 19th. Rather than do that, I can just take 3 times 19, which is 57, and this ends up being z to the 57th power. 64z to the 57th. In question 31, we're going to be using 2 of the rules. First of all, we have to take care of the power to a power. That's the power rule, where we multiply our powers. We take our coefficient to the power. And then after we do that twice for each parenthesis, we're going to have to multiply, which means we're going to be using a different rule. Remember, this is 3 to the first. We multiply exponents. 1 times 2 is 2. In other words, it's 3 squared, which is 9. A cubed squared, that's 2 times 3, a to the 6th. B to the 4th, we're multiplying the powers, and c to the 4th, times, we take 2 to the 3rd power, 2 times 2 times 2 is 8, a to the 6th, b to the 15th, and c to the 9th. So we just use the power rule. The next thing we're going to do is multiply. That's when we multiply our coefficients and we add the powers on like bases. 8 times 9 is 72. A to the 6th times a to the 6th is a to the 12th. B to the 4th times b to the 15th is b to the 19th. And c to the 4th times c to the 9th is c to the 13th. There's my answer. 72, a to the 12th, b to the 19th, and c to the 13th. In question 33, we're dividing, and that is where we divide out the common factors. 24 and 120, if you don't immediately see what it is right off, you could divide by something you recognize. They're both divisible by 12. That would be 2 and 10. But 2 and 10 still have common factors. I can divide them both by 2, and I get 1 and 5. A squared and a to the 4th have 2 a's in common, so I'm going to divide them both by a twice, a squared. Take 2 away above, I have a squared. Take 2 away below, and I'm left with just a 1. No a's at all. Cancel 6 b's from both. This becomes a 1, and b to the 13th, cancel 6 b's, becomes b to the 7th. C to the 5th and c squared, they have 5 c's in common. Divide them out, and you have 1 and c squared. Now these ones don't matter. You can just cross them out. What am I left with? I don't have to put the coefficient of 1, so it would be a squared c squared over 5b to the 7th. You can ignore their directions on question 35. WAMAP added the capability to enter fractions without the parentheses. But keep in mind on 35, you're using 2 rules. You're going to use the power rule. You have a power to a power, parentheses to a power. Everything inside the parentheses is going to be to the 4th power. The 2 to the 4th power will become 16. 2 times 2 times 2, 4 times. A to the 5th, when we have a power and a power, we multiply our exponents. That's a to the 20th over b squared to the 4th power would be b to the 8th. We multiplied our exponents. And c to the 9th to the 4th power would be c to the 36th. Now we would check this and see if there are any common factors above and below. There don't appear to be, so this would be our answer.